Dead room. Sounds like there's not too much going on, right? In the best case, that's true. In the worst case, microorganisms can make that really lively in there. But what about the parameters? Here's the deal. I take you with me and we shed some light into the darkness. With regard to one of our last videos talking about the L/D ratio, we have received some questions from you. One was, what about the flow velocity of my medium, or the viscosity, or the temperature? In order to discuss that in a little bit more detail, it's a great thing to talk about the following graphics here. In this graphics, you need to imagine a T-piece which is considering several flow characteristics. Talking about the flow velocity on the one hand and the L/D ratio on the other hand. And you can see that depending on both parameters, there are cleanable and non-cleanable areas in this graphics. So as the SMBPE, for example, is recommending a flow velocity not below 1 meter per second, you can see that still using 1 meter per second, also an L/D ratio of roughly 3 is okay and cleanable. However, going below this value, you will end up very soon in an area where conditions are non-cleanable. So that needs to be avoided for sure. However, going up with the flow velocity and reach an area of 2 meters per second, you can figure that also an L/D of 4 or 5 would be still okay to be used. However, also this graph is not giving you the whole truth, because there are certainly different, let's say, varieties of flow. And this flow can be described by using or having a look at another scenario. Of course, it's very difficult to take a real look into a stainless steel T-piece as it's not visible what's going on in there. However, the idea is certainly, let's make it out of glass and let's use some particles in the fluid you're pumping through it. And let's set up different flow scenarios. Here you can see that in this setup we are using a 1-inch main tube and a 3/4 inch branch. And as you can see from the flow, the particles really make the problematic zones pretty visible. So when you have the first, let's say, setup with regard to the splitted flow, you can see that there are some areas in the branch and in the main which are kind of difficult to clean, whereas the flow parameters or the velocity of the particles are limited. So those areas need to have a critical view at. However, when we change the flow characteristics and use a bend flow where we have a dead end in the main tube, you can see that probably the 2D area and the 3D area as well are still kind of okay to be cleaned. Whereas the particle movement in there is big enough, large enough to show that there is movement and that microorganisms, or in this case particles, cannot really settle down. However, with regard to the third option, we're having as a straight flow in there and have the small diameter or the smaller diameter branch as a dead end, it's pretty obvious that a 2D distance from the main is still okay, but certainly a 3D distance is not okay anymore. Because here you can see that the particle movement, respectively the bacteria movement, if you wish, is more or less zero. So in this case, it's very obvious why the SMBPE is considering a 2D distance as being okay, and everything above 2D should be not okay, because the ASME BPE is not distinguishing between a branch or the main or wherever the dead end is. However, it's certainly up to you to apply even stricter requirements. So in case of very critical applications, there might even a L/D ratio of 1.5 be applicable and desirable from you. We would certainly be happy if you approach us with your questions and let us be part of your design team. Certainly, I would be happy if you subscribe your questions to you or subscribe to our YouTube channel here. So far, so good. Stay healthy, and I would be happy to welcome you in one of our next videos. Take care.